Hello everyone, I am Frank Noe from FU Berlin and welcome to my deep learning lectures. Today I will introduce you to convolutional neural networks or ConvNets. ConvNets are extremely important as a class of neural networks as they are essential to get state-of-the-art performance in many machine learning tasks such as computer vision. ConvNets are made for data where we have the individual dimensions or the variables at the input in a particular order or topology. So in other words, there's a sense of location and neighborhood in the signal. For example, in images, every pixel has a position in the image and has neighbor pixels around it. Then in time series, such as audio signals, there is the time index, which orders the data. And then for every time point, there's a time before and a time after. In video streams, you have proximity in time and in space, and we can even consider more general topologies, such as graphs, which just connect objects via some edges. And for all of these types of data, ConvNets are very useful. We will see that convolutional neural networks are actually special cases of fully connected multi-layer perceptron layers that we have seen before. But they are very important special cases. So on one hand, they differ by the connectivity between the neurons. Instead of connecting every neuron in the last layer with every neuron in the next layer, we only connect neighbor neurons, so neurons that have a spatial proximity, with the idea that this matters for information processing. And this, of course, vastly reduces the computational effort and the memory cost, simply because we have many less parameters and many less connections to do computations over. But maybe even more important in ConvNets is the concept of parameter sharing. So the idea is if we want to detect a certain pattern or feature in a signal, let's say you want to detect a cat in a picture, then it shouldn't matter if the cat is in the top left or in the bottom right of the picture. You should have to learn to detect cats only once and then be able to apply this independent of where the cat is in the picture. And this can be achieved with parameter sharing. So parameter sharing is the idea that if you have learned parameters to describe a feature or a pattern, they are applied everywhere in the image or in the signal. So compared to multi-layer perceptrons, which do not have this specific structure, sparse connection and parameter sharing, convolutional neural networks are regularizations. So they restrict generality in some sense. They may even give you a larger training error than a fully connected network could, assuming you could train it on your machine learning dataset, which is often an issue for large datasets. But assuming you could do that, you might get a larger training error with a ConvNet, but usually you will get a massively reduced prediction or test error because you are regularizing the learning problem in a meaningful way. So now I will introduce to convolutions, then I will speak about the most commonly used convolutional neural network architectures, and finally make some comparisons to the visual cortex in the human brain in order to give a biological motivation. And with that, enjoy the lecture.